Good morning, students. We will do the remaining problems in the current electricity. See what is the problem. 6 batteries are there, each of 2 volt are connected in series so that they are aiding each other. Internal resistance of each cell is 0.5 ohm. They are being charged using a direct supply of 110 volt. To control the current, a 46 ohm resistor is used in series. Power drawn from the supply is how much? Okay. So what they are asking, say, 6 batteries are there. Okay, 6 batteries. Each battery is having, they are supporting each other like that. They connected 3, 4, 5, 6. They are supporting each other. These 6 batteries are connected across a resistance of 46 ohm and across a battery of 110 volt. Okay, 110 volt. Then what they are asking here is, what is the power drawn from the battery? Okay. Power is equal to V into I. So here what we can write is, all these cells are in the charging state. So in charging, V minus E is equal to I into R plus R. This value will be 110. EMF of the each battery is 2 volt. 6 batteries are there. So I into external resistance is 46 plus 6 batteries are there. Each battery is having internal resistance 0.5. So 110 minus 12 means this value will be 98. I into this value will be 49. So I is equal to 98 by 49. This value is equal to 2 ampere. Power they are asking me. Power is equal to V into I. V value 110. I value 2. It becomes 220 watt. So option for this will be first option. Next. 67, you see, a battery of EMF E produces currents I1 and I2 when connected to external resistances R1 and R2 respectively. What is the internal resistance of the battery? So here there is an external resistance capital R1. Okay, it is connected to a battery. Then current flowing through the circuit will be capital R1. Same battery connected to external resistance R2. Then current flowing through it will be I2. Then what is the internal resistance of the cell? Okay. In case 1, in first case, E minus I1 into R is equal to I1 R1. So E is equal to I1 R1 plus I1 R. Let it be equation 1. Next, in second case, what we can write, E minus I2R is equal to I2 R2. E is equal to I2 R2 plus I2 R. And then equate these two E's. Then what we can write here from 1 and 2. I1 R1 plus I1 R is equal to I2 R2 plus I2 R. You bring this one to this side, this I1 to this side. So I1 R1 minus I2 R2 is equal to I2 minus I1 into R. Therefore, R is equal to I1 R1 minus I2 R2 by I2 minus I1. Okay. So this will be I1 R1 minus I2 R2 by I2 minus I1. Fourth option will be correct for it. See the next question. In the circuit shown in the figure, what is the current flowing through the 5 ohm resistance? I will note some points here. This is A. This will be B. You take any points. C, B, E, F. Current coming from this battery, I am assuming I1. Current coming from this battery, I am assuming I2. So current flowing through the 5 ohm resistance will be I1 plus I2. If we have to find I1 and I2, adding that we will get. Now we'll apply Kirchhoff's second law, applying KVL to AE FBA. That is one loop. So A to E, nothing is there. A, E, nothing is there. So this will be minus I1 plus I2 into 5. Next F2B, nothing is there. Again, here current value will be equal to I1. Here current value will be equal to I2 minus I1 into 2 plus 2, because we are going from negative terminal to positive terminal. This will be plus. So 5I1 to I1 will be 7I1 plus 5I2 is equal to 2. Let it be equation 1. Next, applying KVL to this loop DEFCD. What to write here? See, in this also same, minus I1 plus I2 into 5 minus I2 into 2 plus 2 is equal to 0. Now in that direction of the current, drop will be negative. So here drop will be minus I1 plus I2 into R. When it came to this, here I2 only there, I2 into 2. In the direction of the current we are going, so drop will be negative. Here we are going from low to high, so it will be 2. If we write this one, 5I1 plus 7I2 is equal to 2. Second equation. Now we will solve this two. First we will eliminate I2. That's why first equation I am multiplying with 7. 49 I1 plus 35 I2 is equal to 14. Second equation I am multiplying with 5. 25 I1 plus 35 I2 is equal to 10. You subtract. So here 24 I1 is equal to 4. Then I1 is equal to 4 by 24. This is 1 by 6 amperes. So how much we got here is I1 value is, therefore I1 is equal to 1 by 6 amperes. This I1 value, whether if we substitute in either in 1 or 2, from 1, 7 I1, 7 into 1 by 6 plus 5 I2 is equal to 2. 5 I2 is equal to 2 minus 7 by 6. 12 minus 5 by 6 means 5 by 6. I2 is equal to 1 by 6 amperes. We have to find the net current. Therefore, I1 plus I2 is equal to 1 by 6 plus 1 by 6. 2 by 6 means 1 by 3 amperes. So the current flowing through the 5 ohm resistance value will be 1 by 3 amperes. This is the answer for it. Okay. Next, see the next question, 70, what they are asking. Length of the filament of a heater connected to a cell is reduced by 10%. Power will be how much? Power formula is what? P is equal to V square by R. R is equal to rho L by A. So this is P square A by rho L. P proportional to 1 by L. So P2 by P1 is equal to L1 by L2. Length is reduced by 10%. So it becomes 9L1 by 10, 90 L1 by 100 means. So it becomes 10 by 9. So P2 minus P2 by P1 minus 1. 10 by 9 minus 1. This will be 1 by 9. P2 minus P1 by P1 into 100. 1 by 9 into 100. This is 11.1%. Increase. Increases about 11% will be the answer for it. So this is the answer for it. Second option. Next. 72, you see what they are asking. Incandescent bulbs are designed by keeping in mind that resistance of their filament increases with the increase in the temperature. 100 watt, 60 watt, 40 watt bulbs are having filament resistances. R100, R60 and R40 relation between the resistances is what? So at 100 watt, when power is 100 watt, resistance value R100, power is 60 watt, resistance is R60. Power is 40 watt. Resistance is R40. So 100 watt power obviously greater than 60, greater than, here power is equal to V square by R. So P proportional to 1 by R. That we will use here. So what we know, P100 greater than P60 greater than P40. So this is 1 by R100 greater than 1 by R60 greater than 1 by R40. So fourth option will be the answer for it. Okay. So this is the answer for it. 1 by R100 greater than something. Here it will be R60. This will be R40. Okay. That is the power. Next. See the 74. What they are asking me. Resistance carries a current I. Power loss due to the surroundings is lambda into theta minus theta naught. Lambda is a constant. Theta is the temperature of resistance and theta naught is the temperature of the surroundings. Alpha is the coefficient of linear expansion strain produced. So here power developed is equal to power lost. Power developed will be I square R. Power lost is equal to lambda into theta minus theta naught. So theta minus theta naught is equal to I square R by lambda. So delta theta is equal to I square R by lambda. Strain means delta L by L. Delta L by L value is alpha delta theta. So alpha I square R by lambda. So it will be first option. Okay. Next, see the next question. In the network shown, points A, B, C are at potentials 70, 0, and 10 volt. Power drawn from the circuit is. Now see, here I am assuming potential is V. First, we will find V value. From that, we will find power. So here, this current is, I am assuming I1. This is I2. In this current, let it be I3. I1 is equal to I2 plus I3. So I1 value will be 70 minus P by 10. This is V minus 0 by 20. V minus 10 by 30. Okay. So zeros will cancel. This is 70 minus V is equal to V by 2 plus V minus 10 by 3. So here LCM will be 6. Here 3V plus 2V minus 20. So if you do cross multiplication, 420 minus 6V, 5V minus 20. So 11V is equal to 440. V is equal to 40 volt. We got V value. Then we will find the power value. P total is equal to 70 minus 40 whole square by R, V square by R. 40 minus 0 whole square by 20. Here 40 minus 10 whole square by 30. So if we calculate this value, finally this is 30 and 30 900 by 10 means it becomes 90. This is 40 into 40 by 20. This value will be 80. 30 this value. So totally this is 200 watt. What is the power means? 200 watt. So it will be first option. Clear? Next. After 76, 82 you see. They gave one circuit like this, Wheatstone bridge circuit. What is the PD across this C1? Across the C2, they are asking. I am assuming some points. Here A, next here B. Can take any points. Here C, here take D. Current, what will happen means from the battery, it will start like this. It will come to here. It won't travel through the capacitor. It will travel through the resistor. Later, it will comes to here. Later, it will travel like this. And finally, it will reaches like this. So, in this way, current will flows. So here 400, here 100, here 500, all will be in series. What is the current means? Net potential V by, totally this will be 400 plus 100 plus 500,000. So 2 into 10 power minus 3 amperes. That is the current. Okay. Now PD across AD will be equal to PD across AB plus BD. So VAD is equal to VAB plus VBD. This will be same current, 2 into 10 power minus 3. Here 400, here 100. So 500. So totally it will be 1 volt. Next, VBC is equal to this will be VBD plus VDC. This is 2 into 10 power minus 3. 100 plus 500. This is 100, this is 500. So totally this value 1.2 volt. Okay. So what will be the answer for this is 1 volt and 1.2 volt. This is the answer for it. Next, 88. What they are asking, see. Here there is a circuit given, Wheatstone bridge circuit. What is the current flowing through X? This is a galvanometer. Current flowing through the galvanometer is 0. So it is a balanced Wheatstone bridge. Okay. These two will be in parallel. Na? So P by Q means, so 5. In parallel, effective 30x by 30 plus x is equal to 10 by 20. So this will comes to this 10, 2's will cancel. So 10 is equal to 30x by 30 plus x. So 30 plus x is equal to 3x. 2x is equal to 30. Therefore, x is equal to 15 ohms. That is the value of x. Now, no current is flowing through this. In this 2 amperes is flowing. Here, how much current is flowing in this 2 amperes? How the circuit will be there? Here 5 ohm. Here 30, 15. So how much that will be effective resistance? 30 into 15 by 45. So it will be 10 ohms. Here 10 ohms. Here 20 ohms. All circuit is like this. Okay. So in this 2 amperes current is flowing. In this, how much current is flowing? This and this are in parallel. So, okay. So, what we can write is in parallel. Check this. Here, some current into 5 plus 10. So, I into 5 plus 10 is equal to 2 into 10 plus 20. So this value will be I is equal to 15 to we can say 4 amperes. So in this, how much current is flowing? I'm see here. Here 5 ohms. In this 4 amperes current. Here it is like this. $30, 15. This will be 30. This will be 15. This 4 ampere is dividing. In this I1 current, in this I2 current, I2 is equal to what will happen means I R1 by R1 plus R2. 4 into 30 by 30 plus 15. So 4 into 30 by 45, 15 twos, 15 threes. So I2 is equal to 8 by 3 amperes. Okay. So option for this will be this one. Next, meter bridge. In the left and right gap, meter bridge circuit will be like this. Na? Yes, this is the circuit of meter bridge. So here, this is the left gap, 2 ohm resistance. Here, right gap, 3 ohm resistances are connected. Some balancing length will come. When the resistances are interchanged, balance length is 61 centimeter. What are the end corrections? New type problem. See here. So initially 2 by 3 is equal to 40 by 100 minus 40. X by R is equal to L by 100 minus L. So here No, no, no. What is the balancing length? We don't know here. So we have to find this value. This is L by 100 minus L. So 200 minus 2L is equal to 3L. 5L is equal to 200. L is equal to 40 centimeter. That is the value of L. Later, what they did, I am assuming alpha, beta are the end corrections. Alpha and beta are end corrections. So we can write it as 40 plus alpha by 60 plus beta. Another balancing length will be, this is equal to 2 by 3. So 120 plus 3 alpha is equal to 120 plus 2 beta. 3 alpha is equal to 2 beta. Equation 1. When these are interchanged, new balancing length will be 61 they give after interchanging. (61 plus alpha by 39 plus beta is equal to 3 by 2. 122 plus 2 alpha is equal to 117 plus 3 beta. Okay. Let it be. So how much this will be? 2 alpha minus 3 beta is equal to like this. You bring this 2 alpha to this side. Then 3 beta minus 2 alpha is equal to 5. Here either alpha value or beta value you substitute. Beta is equal to 3 alpha by 2 minus 2 alpha is equal to 5. 9 alpha by 2 minus 2 alpha is equal to 5. This 2.5 alpha is equal to 5. Alpha is equal to 2. Alpha we got, na? Beta we will get in this centimeters. Okay, and then from 1, 3 into 2 is equal to 2 beta. Beta is equal to 3 centimeters. Okay. So 2 centimeter, 3 centimeter will be the answer for it. Next. What they are asking, see 98. Same. Meter bridge is there. Then this is right left gap. This will be right gap. Known resistance 8 ohms and conductor of 4. So here 8 ohms is connected. Here one conductor at 25 degrees centigrade is placed. Balancing length is what they got is 40 centimeter. So what we can write initially, one by 8 is equal to 40 by 60. Then R1 is equal to how much we will get here. This is 2 by 3, na? So 16 by 3 ohms. Later it is heated. Then balancing length changed to 50. Then at that time resistance I am assuming it as R2. R2 by 8 is equal to 50 by 50. Then they are asking what is the alpha value. Alpha is equal to R2 minus R1 by R1 T2 minus R1 T1. So this is 8 minus 16 by 3. Remaining 16 by 3 into 100 minus 8 into 25. Finally, if you get this answer as 8 into 10 power minus 3 per degree centigrade. My next simple questions only. What are this saying? Potentiometer length and balancing length both will be proportionate. Capital L1 by L2 is equal to small l1 by L2. They gave this is small l. Later they made it as 1.5 L. This is L by 5. This is how much they are asking. So L2 is equal to 1.5 L by 5. This value will be 3L by 10. This is the option. Next, 102, what they are asking. 6 identical cells are there. And they are connected in series. Balancing length is L. Then later in that, two are connected wrongly. So E1 by E2 is equal to L1 by L2. So here 6 connected, later 2 are wrongly connected and cancels with 2 and remaining will be 2 only. This is L, this is L2. So L2 is equal to L by 3. 104 that is. Next 114. Balancing length, internal resistance. R is equal to L1 minus L2 by L2 into R. 125 minus 100 by 100 into 2. So this value will be, if we calculate, 25 twos are 50, 50 by 100. This value 0.5 ohms. Next, last problem. Cell is connected to this repeated model. This is here also capital L proportional to L. L1 by L2 is equal to small l1 by L2. Okay, initially second null deflection 2.5 meter is there for 10 centimeters. First initially 10 centimeter is there. Later it becomes 11. This is 2.5. This is L2. This will be 4 times will cancel. L2 is equal to 11 by 4, this is 2.75 meter. 115, third option. Okay, you prepare all of this and remaining we will continue in the next class. Okay, we'll stop now.